Hello, this is Gregory Maxwell, and this is a short lesson on solving linear equations in one variable. This lesson is designed for uh, basic algebra, and this is just a quick review for many subjects. So let us get started into it. Now, some basics of equations. Um, a definition of a linear equation in one variable is basically uh, uh, given here. Let a and b be real numbers where a is not zero. That's the coefficient of the variable x. A linear equation in one variable is an equation written in the form ax plus b equal to 0. In other words, the x has a non-zero coefficient and everything else are constants. And so we're trying to solve for the variable when we're trying to solve the equation. A couple of things we need to remember about properties of equals. Equals has what we call the addition and subtraction properties, which means if you add something to the left side and add the same thing to the right side, the equality is maintained. The same thing occurs if you subtract. So if A equals B, then and I add C to both sides, those two parts will also be equal. And if I subtract the same number from both sides, the equality remains. The same thing occurs if we multiply both sides by the same number, or if we divide both sides by the same non-zero number. We cannot divide by 0 because that does not give a solution. I'd just like to add as well that equals is what we call symmetric, which means that if I say A equals B, then it's also true that B equals to A. Now, how do we solve a linear equation? It's quite simple, actually. I call this the reverse PEMDAS approach, the reverse PEMDAS. We first simplify both sides. We simplify both sides by distributing parentheses, and sometimes if you have fractions, it's easier actually to work with integers and fractions. So you'd multiply by the common denominator of the fractions. Then you get rid of the weakest link first, which in this case, in the case of PEMDAS, the strongest operation is what is parenthetical terms, which is represented by the E, then exponents, which is represented by the E, then multiplication and division are both the same level of strength, and then fourth, addition and subtraction are the same level of strength. So what you would do is get rid of the weakest link first, which would be addition and subtraction by doing the opposite operation. Then if there's a multiplication or division, we get rid of those next by doing the opposite operation, the inverse operation. The inverse operation for addition is subtraction, and the inverse operation of subtraction is addition. In other words, they undo each other. Likewise, the inverse operation of multiplication is division, and the inverse operation of division is multiplication, so they undo each other. And then we will get rid of exponents by doing the corresponding root. So if you have a square, you do the square root. If you have a fifth exponent, you do the fifth root. And then parentheses would be what you would go after next. And then, of course, you will always want to check your answer to see if that works out. So let's try a few quick examples here to illustrate our point. In this case, we want to solve this equation, and solving the equation means find the value of the variable that makes the statement true. So in this case, I will distribute any parentheses that are there, especially if there's a variable inside the parentheses. So I'm distributing the 2 times the y, I get 2y, and 2 times the negative 3, I got negative 6. And now what I want to do next is combine the variables onto the same side. So what I'll do is I'll subtract 2y from both sides so that the variable is together on the right side. And I'll add the 7 plus the negative 6. That will give me 1 on the left side and 4y plus 3 on the right side. Now I want to get the y by itself. I get rid of the weakest link, which is the 3. I'll subtract 3 from both sides. When I subtract 3 from both sides, I get negative 2 is equal to 4y. And now to get the y by itself, I would divide both sides by 4. So when I divide both sides by 4, I get negative 2 over 4, which is negative 1/2, and that would be y. Now, to check if I'm correct, and I won't show all the checking in this video, but you need to make sure you continue to check each time. We simply replace all the variables in the equation with its value. So we're going to replace all our y's with negative half. And if we are correct, then both sides of the equation will work out to be the same. So in this case, on the left side, we have 7 plus 2 times negative half times minus 3 is negative 3 1/2, which can be written as negative 7 over 2. and then we multiply that by 2, we get negative 7. So we get 7 minus 7, which is 0. So we expect the right side to work out to be 0 as well. 6 times negative half is negative 3, and negative 3 plus 3 is 0. So we see that our answer works. So then our solution then is the number negative half. That is the value of the variable y that makes the statement true. No other value of the variable makes the statement true. Let's try this next question here. 4 times t plus 2 minus 6 times t minus 1 is equal to 6 minus t. We distribute the 4 to each thing in the parentheses. Likewise, we will distribute the negative 6. And we'll get 4 times 2t is 8t, and 4 times 2 is 8. Negative 6 times t is negative 6t, and negative 6 times negative 1 is positive 6. And we have a 6 minus t on the right side. In this case, I'm going to move the t that was on the right over to the left side. I'm going to add t to both sides and combine all my t's together. So I have 8t minus 6t plus this new t. That gives me 3t. And then, of course, 8 plus 6 was 14. And then the 6 is remaining on the right side because when I added t to both sides, the negative t got canceled. And then we're going to subtract 14 from both sides and then divide by 3 because we're doing reverse PEMDAS. So this gives me negative 8. And when I divide both sides by 3, I get negative 8 thirds. And then we are going to check to make sure, and you can always use your calculator to verify this. So we do 4 multiplied by 2 times negative 8 thirds plus 2 minus 6 times negative 8 thirds minus 1. Let's see what that works out to be. So 2 times negative 8 thirds is negative 16 over 3. And so negative 16 over 3 plus 2, I'm going to write that to as 6 over 3. And then on the left side, on the next fraction, we have negative 8 thirds minus 3 over 3. So let's write it that way. And then negative 16 over 3 plus 6 over 3 is negative 10 over 3. So I have 4 times negative 10 over 3. And then we have that's minus 6 times negative 11 over 3. And we put those together. We have negative 40 over 3 minus 66 over 3. And that gives us negative 106 over, oh, that's a plus, my bad. Negative 40 plus 66 gives me gives me 22 over 3. Now on the right side, we have 6 over 1 minus negative 8 over 3. I'll write that 6 over 1 as 18 over 3 plus 8 over 3. And it seems we have a different answer here. So let's check to make sure we did the work right. 8t plus 8 minus 6t plus 6 equal to 6 minus t. 8t minus 6t plus t is 3t, and 8 plus 6 is 14. 6 minus 14 is negative 8. So we did our work right, so my checking was incorrect then. Negative 16 over 3 plus 6 over 3 is negative 10 over 3. And negative 8 over 3 minus 1 is negative 11 over 3. And negative 6 times negative 11 is negative 60, is positive 66. 66 minus 40 is 26. So I just made an error right here. So it turns out to be the same thing. So my checking was just where the error was. That is not a problem. So we are correct. So my solution then is negative 8 over 3. Let's continue with the next example here. We again are going to distribute the parentheses, but let's do it systematically. We're going to distribute the right side. That is easy, but let's distribute the parentheses here first, and then we'll distribute the bracket afterwards. So we have 3 bracket p plus 2p minus 4 equals to 4p minus 12. And then 3 times p plus 2p is 3p minus 4 still equals to 4p minus 12. And then 3 will just get this just distributed to that bracket. And so we have 3 times 3p is 9p minus 12 is equal to 4p minus 12. Now I just subtract 4p from both sides, and then that will give me 5p minus 12 equal to negative 12. And then, of course, to get the p by itself, I add 12 to both sides. And once I add 12 to both sides, I end up with 5p equal to 0. And then I divide both sides by 5, I get 0. And if I try that, I plug in 0 for p, I will get 2 times negative 2 is negative 4, times 3, which is negative 12, and then 4 times negative 3 is 12. So a quick check indicates that that is the correct answer. So my solution here is the number 0. So we have 3 examples here of work of solving a simple equation with one variable. Now let's talk a little bit about a couple of additional tips here. Just a quick tip. If you have fractions in an equation, what you want to do is multiply by the common denominator. And if you multiply by the common denominator, then you can work with whole numbers instead. So the common denominator really means the least common multiple of the denominators. In this case, the least common multiple of the denominators, shorthand written LCD, least common multiple of denominator, is 4, a number that both 4, 2, and 3 can all go into, and that number, of course, is 12. So what I will do is I will take each term, or each side actually, and I would multiply each side by that common denominator. Since I'm multiplying both sides by the same number, then I'm not actually changing the equation. I will just get an equivalent looking expression. So I'm going to multiply the left side by 12, left side of the equation by 12, and the right side of the equation by 12, which means each term will get multiplied by that 12. So in doing so, I would end up with 3/4 A multiplied by 12 and half multiplied by 12. So that's 12 over 1 times 3/4 A and half times 12 over 1. And on the right side, I have 2/3 A. That will be multiplied by 12 as well. Let me write it in front because of commutative property of multiplication. I don't have to worry about writing it before or afterwards. So 12 2/3 A plus 1/3 times 12. And then when I do that, look at what happens. This 4 cancels with that 12, leaving 3. This 2 cancels with that 12, leaving 6. This 3 goes into that 12, leaving 4. And this 3 goes into that 12, leaving 4 again. And then I just multiply the numerators, and the denominators are all 1. So 3 times 3 times A is 9A, which would be over 1. And then plus 6 is equal to 4 times 2A is 8A plus 4. And this becomes a simple equation to solve now. I simply subtract 8A from both sides, and then I would subtract 6 from both sides, and my answer becomes A is equal to -2, which if I check it, it will work. 3/4 times -2 is -3/2, plus half is -1. 2/3 times -2 is -4/3. Plus 1 is -3/3, which is -1. So that works. So my solution then is -2. All right, let's take a quick look at a couple of types of equations that we will get in this type of situation. There are three of them. One is a conditional equation, which we've been doing, a contradiction, and an identity. The solution to a linear equation is the value of x that makes the equation a true statement. A linear equation in one variable may have one unique solution, no solution, or infinitely many solutions. Let's see the cases here. In a conditional equation, an equation that is true for some values of the variable but false for other values of the variable is called conditional. And so an example, x minus 6 equals 5. This statement is only true when x is equal to 11. So it's true on the condition that x is equal to 11. It's false every other time. And then we have what we call a contradiction. A contradiction is an equation for which no value of the variable makes the statement true. So if we try to solve the equation, we will get a contradiction, a statement that is never true in the context that we're solving here. So this indicates that the equation actually has no solution. I just made a quiet error here. So let's see. So we have 2 times x plus 5 is equal to 2x minus 7. Let's try to solve this. What we will do is distribute the 2x, the 2 to the x and the 5. So we'll get 2x plus 10 is equal to negative 2x, equal to 2x minus 7. Then I would subtract 2x from both sides. When I subtract 2x from both sides, all I'll be left with is 10 is equal to negative 7. 10 is not equal to negative 7 in the real number system, so that is a contradiction. That's a statement that is never true. So we have no solution to this equation. There is no value of the variable that works for this equation. No solution. Let's try. The third situation is what we call an identity. So an equation for which all real numbers are solutions is called an identity. When the left and the right hand side of the equation work out, they are simplified. You get identical equations on both sides. So that means whatever value of the variable I plug in, we get the same statement, the same result on both sides. The statement is always going to be true, no matter what variable I insert. So here's an example. 3 times the quantity x plus 5 minus 3 is equal to 3x plus 12. First things we do, we'll distribute the 3 to the parentheses. We'll get 3x plus 15 minus 3 equal to 3x plus 12. Then when I combine the like terms on the left side, I get 3x plus 12 equals to 3x plus 12. If I subtract 3x from both sides to get the x's together, I get 12 equal to 12. 12 is always equal to 12. This statement is always true. So the solution to this equation is all real numbers. Every value of x I substitute into this equation gives me a true statement. So I'm going to illustrate by doing 2 quick examples here. We're going to determine whether these are conditional, an identity, or a contradiction. So for this first one here, I'm going to distribute the 2 to the parentheses and then simplify the left side and the right side. So we have negative 10x minus, minus 2 on the left. And on the right side, we have 2x minus 12x is negative 10x plus 6. Now to get the x's together, I simply add 10x to both sides. And when I do that, I end up with negative 2 on the left is equal to 6 on the right hand side. This is not possible. That is always a false statement. Always false in this system. So therefore we say that this is a contradiction. There is no solution. And so we're dealing with a contradiction. A statement that is false automatically all the time. On the right side, we have another example here. We'll distribute the parentheses in both sides of the equals. And then we'll see what we get. We get 6x minus 2 on the left, and we get 6x plus 8 plus 6 minus 8 on the right hand side. We combine like terms and we subtract 6x from both sides to get the variables together, and we end up with a negative 2 on the left and a negative 2 on the right hand side. That statement is always true. This is always true. And because this statement is always true, we are dealing with an identity. So the solution to this then, the solution to this system is all real numbers. That means no matter what value of x I plug into this equation, I will get the same, I get the same thing on both sides. The statement will always be true. So we're dealing with what we call an identity. And an identity is an important type of equation in mathematics. Let's do a few more examples, and then that will be the end of our short lesson. In this case, we have fractions, and so what we'll do is multiply both sides by the common denominator of the fractions, which you can see here is 8. And so I'm going to multiply each term by 8. And those terms that have a fraction, I'm going to put the numerator in parentheses so that we don't get overlook that. So I'm multiplying the left side by 8 and the right side by 8. So this 4 goes into this 8, leaves 2. This 8 cancels this 8, leaving 1. And this 2 goes into this 8, leaving 4. So we end up with this equation here. 2 times 5 is 10 plus y minus 3 is equal to 4 times 2y plus 1. And now I'm putting this in parentheses because I had it there, and if this was a plus, that would have mattered. But since it's if this was a minus, sorry, that would have mattered. But since this is a plus, it doesn't change anything. And in this case, we're distributing the 4 to each term. And when we do that, we end up with 10 minus 3 is 7. And we're going to subtract y from both sides. So when I subtract y from both sides, I get 7 is equal to 7y plus 4. So that means 3 is equal to 7y. So that means y is equal to 3 over 7. And that statement, that's a conditional statement because we're saying that this statement is only true. This statement is only true when y is equal to 3 over 7. We only have a limited number of solutions. Let's take a look at this other example here. This one is just decimals. Decimals are not a problem. We just work with them as we would normally. Just be careful of where you put the decimal point. So we're distributing the parentheses, and then of course we're going to multiply 0.06 multiplied by 140, and that gives you 8.4. So we have 8.4 minus 0.06w is equal to 90. Now when I put 0.07 minus 0.06, the w's, we get 0.01 w minus 8.4 is equal to 90. And then I add 8.4 to both sides, I get 0.01 w is equal to 98.4. And then if I divide both sides by 0.01, and again, you can simply do that on your calculator. You'll get W is equal to 9,840. And we can always check. If you multiply 0.07 by 9,840, that will give you 688.8. And then if you do 140 minus 9,840, you get negative 9,700, which you will then multiply by 0.06, and that would be negative 582, which you add to the 688.8, and the left side works out to be 106.8. So there is an error because both sides are supposed to work out to be the same. So let's just check to make sure I didn't make an error here, and indeed I did. I made an error in my plus here. So this is important to make sure that you pay attention to your signs, because right there I made an error. Instead of having a plus, I should have had a minus. So we have 90 minus 8.4, and that should be 81.6. And now when I divide, I should get 8,160. And then we can check that. So we do 0.07 multiplied by 8,160, and then plus 0.06 multiplied by 140 minus 8,160. And then we work that out, and it turns out that both sides work out to be the same. So that means my solution is 8,160, and we're talking about a conditional equation. And our last example is simple. We just combine like terms on both sides. 2x plus 8x is 10x minus 4, and 7x plus 3x is 10x minus 8. I subtract 10x from both sides, and I end up with just negative 4 equals to negative 8, and that means this is impossible. And so what we have is no solution, and then with no solution, we then say this is a contradiction. And that is the last of our lesson for today. I encourage you to look at Khan Academy for additional videos and practice, as well as if you're using a textbook, you look at the examples for the textbook. The only way to get good at doing mathematics is by reviewing, studying, and a lot of practice. That's all for this lesson. All the best to you.